All right, so this object is projected vertically, and its initial velocity is 20 meters per second. Of course, we've got gravity, and we've got some air resistance. So it's 1/40 v squared. If you're confused whether that's newtons or whether it's not newtons, it's fine because our mass is 1 kilogram, so that's helpful. So even if we divide it by 1 or we weren't sure, we'd get the same answer. Very handy. All right, so you can see that our acceleration equation, it's going upwards, so we've got negative gravity going downwards and negative v squared on 40 going downwards there. So we're interested in the distance, the maximum height, again, greatest height reached. So we know we want, that occurs when v equals 0, so we want v to v dx here. So let's make sure we've got that on a common denominator first. All right, once we've done that, we make, tip everything upside down. So let's put that minus 40 at the front, and we've got 400 plus v squared to v here, and we're going to have a v up here as well. So you can see here we're going to need a 2 to make the log work, and so I'll divide that by 2 as well. So we've got a minus 20, we've got a log 400 plus v squared, and if you want to make a definite integral, our velocity started at 20 and we're going all the way up until 0. So 20 to 0. I can get rid of that negative by subbing in the 20 first, so just reversing those limits. So when we sub in the 20, we're going to get v squared is 20 squared, so we've got 400 plus 400, so we've got 800 on top. When I sub in 0, I get 400. So you can see we're going to get the maximum height being 20 log 2 meters. All right, so the next part, show that okay, so now we want the time taken. So instead of that, I'm now going to go for v to t, so I can introduce time. Okay, so again, okay, just putting it on a common denominator and tipping it upside down. I'm going to put the minus 40 at the front, so I've got the 400 plus v squared there. This time I only have a v. So the time taken, again, my velocity, I'm going from 20 up to 0. This makes it easy there. So we've got minus 40, so this will be an inverse tan. Inverse tan v on 20, and so I need the on 20 there as well. We're going from 20 to 0, or if we take note of the negative out the front, I can sub 20 in first. So when I sub 20 in, I get inverse tan 1. When I sub 0, I get inverse tan 0, which is just 0. So, I mean, I could put it here, but I don't really need that. So inverse tan of 1 is pi on 4, so we're going to have 2 lots of pi on 4s, which, sorry, I've run out of room, is pi on 2. So the time will be pi on 2 seconds when it reaches that maximum height. All right, excuse me. So it reaches its maximum height and then it falls back towards the earth or the ground or wherever it is. So if we're looking at our new equation, because now positive is down, so we've got positive gravity going down, so that's going to be positive, but again we've still got resistance, so resistance is opposite the direction of motion. What are we looking for? So we're looking for the speed of the object, so we'll just look for the velocity when it returns to its starting point. So when it's been through, if I started at x equals 0 this time, I know that it's going to go through 20 log 2 displacement for it to return to its starting point. So we've got v's and x's, so v to v dx. V to v dx, and again, that was a gravity of 10, so I'm going to make it 400 on v squared on 40 to give it a common denominator. And here, I do it a bit slowly. So when I turn this side upside down, so I've got the 40, I've got 400 minus v squared to v again, and I'm also going to have a v here. And remember, this, to make it a log, I need a -2, so I'm going to have a -2 here as well. On the other side, I'm integrating x, and remember we said x is going from 0 to 20 log 2, so I know this is going to be 20 log 2. But otherwise, if I'm using definite integrals, I'm saying I'm going from 0 up to 20 log 2. So I do get 20 log 2 when I do that. Okay, so on this side I've got -20, and now I'm logging, so my velocity, I'm going this time, because it's dropping, I'm going from 0 up to some velocity, which is what I'm trying to find. So I've got -20 log of 400 minus v squared, and going between 0 and v. So you can see those 20s will cancel. So I've got log 2 is equal to, I'll change my limits around so I can have a positive log. So I'll sub 0 in first, and I'll get 400. Then I will sub v in, so I've got 400 minus v squared. Alright, so you can see there, they're both logs. So if I just change it to, if I exponentialize both sides, I've got 2 equals 400 on 400 minus v squared. So I've got 800 minus 2v squared being 400. So you can see I'm going to have 2v squared equals 400. So v squared is going to be 200. So square root of 200 is 10 root 2 meters per second. Now it is speed, because I'm not worried about direction, so that's just your working. And say therefore speed is 10 root 2 meters per second.